benefit of those who are not able to attend. And I'm going to share my screen. And I want to take a look at the course in D2L. There are two announcements that I want to point out. One is that there is a bonus opportunity if you complete the course evaluation. You should have already received an email to your Georgia Highlands College email account. It does not come to your D2L account. You have to go into your GHC student email. And it has a link that is unique to you and unique to the course for Business 3000. Once you've completed it, you can take a screenshot of the thank you and then post it to the folder that is linked here in the announcement. And you have until next Monday to do that to earn 5 bonus points, which are just added, to your point total before I actually do the grading. I do not see those results of that evaluation until well after grades are posted. Unless you include some identifying information, it is completely and totally anonymous. Secondly, there is an announcement about the final exam. I created a couple semesters ago a review for the final exam such that the questions are formatted in the same way that you'll see them on the actual final exam. They're formatted really the exact same way that you've seen them on the homework problems throughout the semester. You can earn 10 bonus points for completion of that particular review sheet. The final exam does open on Monday, December the 5th, and will close on Saturday the 10th. There is an attachment to that announcement that has additional information. I already have that one pulled up. So the final exam is not proctored. So that means you can use your notes your handwritten notes that you've taken throughout the semester, the notes that are provided in D2L, the flowcharts, PowerPoints, practice problems, homework problems, whatever, during the final exam. You will have to access and use Minitab. So you need Minitab instructions, which I've provided to you throughout the semester, or at least walked you through and you've made your own notes. But in case you didn't do that or whatever, there is a folder in D2L labeled Minitab instructions. They are grouped by modules, and you'll see in a minute that the final exam only covers Module 3 and Module 4. So you can click on those links and you're going to see the instructions for the different tests that were covered in that particular module. So in case you didn't write them down or you've forgotten them, it is available there. It does open on Monday the 5th, will close on Saturday, December the 10th at 11:30 p.m. I have to give it a time limit. I've allotted 3 hours for you to take the final exam. However, if it takes you longer than 3 hours to take the exam, it is not going to cut you off. Okay, it will just simply notify me that you took longer than 3 hours. You do have to take it in one sitting. You can't start, stop, start, stop. You have to take it in a 3 hour, or if you want a lot more time, a 3 to 4 hour window. You only have one attempt and there's no makeup. It is multiple choice and fill in the blank, much like you have seen on the midterm and throughout the semester on your homework problems. I will actually be reviewing each submission of the final exam for errors in rounding, or if you don't put the leading zero, or if you misspell something, I'll be going through and checking for those things. And then it gives you a breakdown of the type questions that you are going to see. The final exam only focuses on module 3 and module 4, which basically is hypothesis testing. We've done all different types of hypothesis testing, from normality to a one mean T or a one mean Z. We've done the chi-square, goodness of fit, test of homogeneity, or test of independence. We covered Anova, or analysis of variance, correlation and regression. We've done one proportion, two mean. So we've covered a variety. So there are 10 scenarios or 10 sections on the final exam, and each of them is a hypothesis test, and it gives you the breakdown of the questions there. There are 75 questions. They're 2 points apiece, and the final is worth 150 points. So before we move on, do you have general questions related to the final exam? One other document that I think would be very helpful to you is one that I posted in the announcements a few weeks back, entitled, "Which Test Should I Use?" I think that's been one of the struggles along the way, and we've talked about it, how to know which test to do. And up to date, you've had, all the problems in a particular section were just the one mean Z or just the one mean T. So now on the final, they're all mixed together and you have to decide. And so I put out this document several weeks ago under the announcements. It gives you the list of all of the parametric tests and non-parametrics that we talked about. The focus on the final is the parametric test. I will tell you that. And so this document, you may want to print it out from the announcements and have it with, nearby when you're preparing to take the final, so it can help you make a decision about which test you should conduct. Again, also I pointed out that if you needed them, you have the mini tab instructions under a folder, under the content, on the right-hand side, labeled mini tab instructions. So my plan tonight is to look at the final exam review. I'm hoping we can get through all 10 questions. I don't know if that will be possible or not. So if you want to kind of glance through them and see if there's one particular one that you want to see, I'm happy to do that. Otherwise, I'm going to start at the beginning and work my way through. But I don't want to waste too much time either. So if you've taken a look at it and you have a particular one you want to see, you can put it in the chat or speak up, and I'll be happy to work that specific scenario or specific problem. I will tell you that in terms of the test, it's going to be important that you carefully read the question. And what I would do is read through the question and work it out as if we were doing it here together in class on paper before you ever try to answer the questions underneath that scenario. I think it's confusing if you try to read it and then read the first question. what is the Anderson-Darling value for normality on the variable debt? Okay, and you are jumbling around trying to figure that out. And then you go to the next question. To me, it's easier and even a little bit more organized if you'll read the question and work it out on your paper first, and then go back and fill in the answers. So that's kind of how we're going to do it. It says, using the following mini-tab data, answer the following questions about the test for normality. So even from the beginning here, it's important that you read the question, because this question tells you that these questions are related to the test for normality. And so it says you will need to download the data set and run a normality test. Use a 0.05 level of significance. And then, having read the first question, I've determined that my variable is going to be the debt. So if I'm thinking about the test for normality, which was a hypothesis test, we begin as we do with any hypothesis test, and we state the hypotheses. So for the test of normality, hopefully you have your notes organized. That would have been the first topic in Module 3, right after the midterm exam. We would say that debt, which is the variable we're interested in, follows a normal distribution. The intent with that phrase is that the null hypothesis there implies that it is equal or follows a normal distribution. The alternative then has to imply not equal, and so we would say debt does not follow a normal distribution. The second step, if you'll recall, in the hypothesis test is to identify the players. In this particular problem, we have been given a link to the raw data, and we're going to have to download that data and then import it into Minitab. We also need our level of significance, or alpha, which is 0.05. It tells us that in the last sentence. So I need to get things set up. So I'm going to open the link. It takes me to a data set inside Minitab, and I'm going to download it. But remember, guys, you cannot open this file on your standard computer. You have to be inside Minitab to open it. But I'm going to download it first, and I'm going to save it on my desktop. Then, without doing anything else, I go directly to Minitab, and I tell it I want to open a worksheet. We've been doing this all semester. It should not be a new process. And the worksheet that I want to open is the loan applicant. Now, I have 8 different variables here, but the one I'm interested in is debt. That's what the question was about. I'm doing the test for normality. So I have my data pulled in to Minitab. So now I am ready for step 3. Step 3 in the process is to calculate the test statistic. And in this case, the test statistic is Anderson-Darling and its p-value. Now it's been a while since we did that, so you may have forgotten the keystrokes. It is stat, basic statistics, normality test. Stat, basic statistics, normality test. I have to indicate the variable, no percentile lines, and we are using Anderson-Darling, and I click OK. And if we recall, it comes up with a graph called a probability plot. Okay, so we get our graph. And on that graph, on the right-hand side, it gives us our Anderson-Darling value and the p-value. So I'm going to record. Record means write it down. So my Anderson-Darling test statistic is 3.211, and the corresponding p-value, it actually says, is less than 0.005. We're just going to say that it's equal to 0.005. And so there is my test statistic and its p-value. So then step 4 is we have to make a decision. We always make a decision by comparing the p-value to the level of significance. So my p-value, which comes from Minitab, is 0.005. My level of significance from the problem is 0.05. We compare those digit for digit. 0 to 0, 0 to 5. 0 is less than 5, so P is less than or equal to the level of significance. When P is less than or equal to the level of significance, we reject the null. Now, think about what that means in the context of this problem. If we reject the null, that means the null is false and the alternative is true. But if you'll recall, this was one of the first hypothesis tests that we conducted, and the statement of the conclusion is written just a little bit differently from all of the others. It says preliminary analysis of the variable debt shows that it does not follow a normal distribution as assessed by Anderson-Darling. Now again, I may have it written in out in words, and those words may be phrased slightly differently from what it would be on the test. So if I go back out here and look at the quiz itself, the questions are in a little bit different order, but it's not a big deal. What is the Anderson-Darling for normality? It was 3.211. My p-value was 0.005. My null hypothesis is that it follows the normal distribution. The alternative is that it does not. And my conclusion is that in this case, it is not normally distributed. Guys, you're going to have to pay attention. That one word, not, is important in the conclusion. You got to make sure you pick the right one. Again, it's worded slightly differently from mine, the way that I wrote it, but again, you have to be, we found that we reject the null, which means the alternative is true, and the variable is not normally distributed. Okay, then we move on to scenario 2. Scenario 2 reads, a survey claims that the average cost of a hotel room in Atlanta is $69.23. To test this claim, a researcher selects a sample of 30 hotel rooms and finds the average cost is $68.43. Assume the population standard deviation of $3.72. At a 0.05 significance level, is there enough evidence to reject the claim that the average cost of a hotel room in Atlanta is $69.23? So one of the first things that you have to decide is which test are you going to do? And there's some words and phrases in here that are important to notice. It has the word average. Okay, so remember, average is another word for the mean. So we're talking about a mean as opposed to a proportion, which is usually given as a percentage. And they're only talking about one thing. They're talking about the cost of a hotel room. So that tells me that I have one mean. And with one mean, I have to decide whether or not it is a Z or a T. And if I look at about the third sentence, it says, assume the population standard deviation of $3.72. Well, because I know or am given the population standard deviation, I'm doing a one mean z-test because I know the population standard deviation. Now, again, we talked about how I know that it's a mean as opposed to a proportion as well. So now that I know which test I'm going to do, I can begin the hypothesis testing process. Step 1, as always, is to state the hypotheses. So we have our null and the alternative. And if I'm not mistaken, that statement is at the end of the problem. It says, enough evidence to reject the claim that the average cost of a hotel room in Atlanta is $69.23. Well, in that statement, I see the word is. Mathematically, is implies equal. And if the hypothesis statement or the claim contains equal, that makes it the null, because the null hypothesis always and forever contains equal in some form. So I have the average or the mean is $69.23. That's the one that's given. I then know by default that the alternative is the exact opposite. The opposite of equal is not equal. So the mean does not equal $69.23. By the way, several of you on your last projects did not include that population parameter. Guys, you have to put the mean or the proportion symbol, because that is the parameter that you are testing. And if you don't put it, the researcher doesn't know. So you got to make sure you have that in the statement. Then step 2 is to identify the players. Now you may have forgotten what the players are for the one mean z-test, but hopefully you have it written down in your notes and you can go back and look it up. Now, I happen to know what they are. You have to know the population mean, the population standard deviation, sample mean, sample size, and your level of significance. And for Minitab, we need the confidence level. All of that is given in the problem. The population mean comes from the hypothesis, which is $69.23. The statement I have highlighted in teal above says to assume that the population standard deviation is $3.72. If I back up to the second sentence in the problem, it says a researcher selects a sample of 30 hotel rooms and finds the average cost is $68.43. That gives me my sample size. It was $68.43 for 30 hotel rooms, and the problem tells me to use a 0.05 significance level, which means my confidence level is 95%. So from the problem, I'm able to identify all of the information that I need in order to work the problem, which takes me to step 3, where we calculate the test statistic. And again, for this problem, that's going to be a Z, because we know the population standard deviation. So we're going to use Minitab to calculate the test statistic and its p-value. So I'm going out to Minitab. If you want to get a clean worksheet, you can. Kind of get a clean slate so you don't get confused. We go to Stat, Basic Statistics, one sample Z, as in zebra, because we decided we know the population standard deviation. We have summarized data. My sample size was 30. My sample mean was $68.43. The known population Standard deviation is $3.72. We are performing a hypothesis test. Our hypothesized mean is that it is $69.23. We check our options. It is a 95% confidence level, and we are doing not equal in the alternative hypothesis. I click OK. I click OK again. And my results appear in the top window. We do have to scroll down. We're looking for the test and the results. And those results give you the p-value, or excuse me, the z-value, or the z-test statistic, and the corresponding p-value. We record them, write them down. So the z-test statistic is negative 1.18. The p-value is 0.239. Then step 4 is we make a decision. We make our decision by comparing the p-value to alpha. So I have 0.239, the p-value from Minitab, compared to 0.05, which was the level of significance from Minitab. We compare it digit for digit. 2 compared to 0. 2 is greater than 0. The p-value is greater than alpha. When p is greater than the level of significance, we fail to reject the null. Thinking about what that means in this problem, if we fail to reject the null, that means the null is true and the alternative is false. Based on the evidence that we have proven that the average cost of a hotel room in Atlanta is $69.23. So the last step is to write a conclusion. Now, once you get into these particular type hypothesis tests, we write them in kind of the standard way. At the 0.05 level of significance, the average cost of a hotel room in Atlanta is $69.23. Any questions? Stop me if you have one. Scenario 3 says a researcher reads that the marital status of U.S. adults is distributed as follows: never married 30%, married 56%, widowed 3%, and divorced 11%. He selects a sample of 400 people, and the results are shown below. At the 0.05 level of significance, can it be concluded that the marital status of the U.S. adults is as he I changed pronouns there, as he read or as stated. So again, my first decision here has to be, what test am I doing? So if I'm looking at this problem, it's asking me about marital status. And the response that we get is in words, which gets us to qualitative data. We only talked about one type of test to use with qualitative data, which was chi-square. But there are 3 different chi-square tests. You had goodness of fit, test of independence, and test of homogeneity. If we look at the document, which test should I use, and look at the options for chi-square, for goodness of fit, we need qualitative data where we've had a single survey question, and we're usually asked, does the distribution fit, follow, match a particular distribution? For test of independence, I need 2 qualitative variables, 2 different survey questions. Test of homogeneity, I have 1 question, but 2 groups, or more than 2 groups. It could be more than 2. Okay, so based on that, I feel like I have, in this problem, I have the chi-square goodness of fit. Okay, it's marital status, which is words, it's qualitative. With only 1 question, I would ask you, what is your marital status? Okay, and it asks me, can we conclude that it is as read or as stated? So it's asking, does it follow that particular distribution? So this test is the chi-square goodness of fit. And then we can begin the process as we always do. Step 1. Let me move that down so that I can do something else here in a minute. Step 1 is to state the hypotheses. Now, if you'll remember, when we talked about this, that for chi-square goodness of fit, the null hypothesis will always be stated in a way to imply equal, and the alternative will be stated in a way to imply not equal. So, and if you read the question, it says, can it be concluded the marital status of U.S. adults is as he has read or as stated? Okay, so hopefully the idea that we want it to be the same or is as stated, it gives you that sense of equality. And you could really use that statement. The marital status of U.S. adults is as stated. Now you could list out what that statement is, okay, but it's not a requirement. So if the null is or equals, then the alternative would be that it's not. The marital status of U.S. adults is not as stated. And again, you could list that statement out. Now, again, the hypotheses, the way they're worded on the final, could be slightly different. I didn't word the questions. They were written by another instructor, and so they could be written differently. But again, guys, if you remember the premise that the null has to include equal and the alternative does not. So it says, for this question, the marital status fits, equals, is the same. So that would be the null. And the alternative would be does not fit. Okay, so please take your time and read the words. Know what you're looking for. Know that the null has to imply equal. So the idea is that it fits or follows, and the alternative is not. The second step in the hypothesis test, I'm going to write it up here because the second step is to identify the players. And really for this problem, the players are this table. What you have given here, you've been given the word or the response, and then the number of US adults. This would be your observed. This is what happened in reality. And then we also have in the paragraph, it's not on the table initially, but we can add it. We have the expected percentages that are given in the first sentence. Now, those percentages have to be converted to a decimal. So if I go back and read them, it says 30% never married, 56% were married, 3% widowed, and 11% divorced. So I just pulled that information that was in the first sentence and added it as a column to the table, because I'm ultimately going to enter that information into Minitab. The other piece we need, as always, is our level of significance, or our alpha, which is 0.05. The third step, as always, is to calculate the test statistic. And for this problem, that test statistic is chi-square goodness of fit and its p-value. So I wrote down these numbers earlier so I would have them. We'll go out to Minitab, and we're basically going to recreate that table that was in the problem here in Minitab. The first column is going to be your marital status. The second would be the observed number of people. The third column is the expected percentage. Okay, so I've put my column headers in there. My categories were never married, married, widowed, and divorced. From the table, my observed, there were 150 never married, 228 married, 5% or 5 that were widowed, not percent, and 17 divorced. Again, my expected percentages were that 30% were never married, 56% were married, 3% were widowed, and 11% were divorced. Again, you have to enter them as decimals. Then we're ready to calculate. Once you've entered that table, it does sort of look like the table that was on our paper. Stat, tables, chi-square goodness of fit test. Stat tables, chi-square goodness of fit test. I have to indicate where my observed counts are. They are in column 2. We labeled them observed. My category names were in column 1. We use an input column, and we are doing proportions specified by historical counts. That is our expected. Proportions specified by historical counts. And I click OK. Now, I want to bring one thing over to the paper to point out. I know we talked about this. This is not the p-value, but I want you to realize that Minitab does calculate the expected values for you. Okay, Minitab does calculate on the table at the beginning of the results labeled observed and expected counts. It does calculate those for you. I point that out because if you look at this question in D2L, let me get back up here to it. Sorry, I'm in the wrong place. Well, it doesn't ask you. Okay, I thought it asked you for the expected, but it doesn't. Okay, but if it did, you would be able to find those on this table. We would have expected 120 to never marry, 224 to marry, 12 widowed, and 44 divorced. So should you need it, Minitab has calculated those values for you. The chi-square test gives us the test statistic that we're really looking for. Well, are you going to let me paste? Okay, so it does give us the chi-square, test statistic and its corresponding p-value, which you record. Write it down. Chi-square goodness of fit is 28.2229, and my p-value is 0.000, or just flat out 0. Then step 4 is we're going to make a decision. You have your p-value compared to your level of significance. My p-value was 0.000. My level of significance is 0.05. If I compare that digit for digit, as we always do, I have 0 compared to 0, 0 compared to 5. 0 is less than 5, so P is less than or equal to the level of significance. When P is less than or equal to the level of significance, we reject the null. So what does that mean in this problem? If we reject the null is false and the alternative is true. So based on the evidence we have, the marital status of U.S. adults does not or is not as stated. It doesn't follow the distribution as stated. So step 5 is to write our conclusion. Remember, your conclusions should always include the level of significance. So at the 0.05 level of significance, marital status of U.S. adults does not follow the stated distribution. And again, you could write out what that distribution was. You know, you could say 30% never married, 50% married, 3% widowed, and 11% divorced. Remember, the details are important in your conclusion. Questions? All right, scenario 4. Yes, ma'am.
I'm sorry, I have a quick question. So, like on the review, or in most of our, quizzes and stuff, it asks us to round to the nearest whatever. So on this one, it says round to the 2 decimal places. So when and I may be slow, I don't know, but sometimes when I'm taking the quizzes, I round up. Is that necessary, or should I just like leave it as it is? Like
you should follow standard rounding rules. So if it says for this chi-square goodness of fit, which Minitab gives us 28.2229, and it says to round to 2 places. So here's 1 place, here's 2 places. Next door to that second decimal place is a 2. Since it's a 2, we leave it alone. But if that had been 5 or higher, you round up. Okay, that's the standard rounding rule. 4 or less, you leave it alone. 5 or higher, you round up. So you would type 28.22. Now, Jada, this is one of those problems that I would be going in and looking at your paper, and if I look at it and see, oh, she rounded up instead of leaving it as 2.2, then I'm going to give you credit for it. Okay. But ideally you follow the standard rounding rules that you probably learned way back in maybe 1st or 2nd grade.
Yeah, I think I just made a couple simple mistakes then in previous quizzes with the rounding.
There is one of them, and I can't, if we come across it, I'll probably remember it then, but there is one of them where you automatically round up regardless, but I can't remember which one that is right off the top of my head, Jada.
That's fine.
If I come across it, I'll make that comment.
Okay, thank you.
Other questions? All right, we're up to scenario 4. Scenario 4 says, suppose a group is interested in determining whether teenagers obtain their driver's license at approximately the same average age across the country. Suppose that the following data are randomly collected from 4, it says 5, but it should say 4, teenagers in each region of the country. The numbers represent the age at which teenagers obtain their driver's license. Use a 0.10 level, use a level of significance of 0.10 or 0.10. So again, one of the first decisions you have to make is what test are you going to do? Okay, so when I'm looking at this, I have ages, which are numbers, which means I have quantitative data. Whoops. But that quantitative data has been grouped. Okay, it's been grouped or sorted by region. And the region is a word which is qualitative. So if I kind of scan my document for, something where I have a qualitative and a quantitative, and let's see, I kind of know what the answer is. So it is One Way Anova, because we take quantitative data, numbers, sorted into groups using qualitative words or categories. Okay, so this particular question is Anova. Analysis of variance. So then we begin the process. My null is going to be that the mean or the average age of teenager, when the mean age, and there's lots of ways to word it, the mean age when teenagers obtain a license is the same for each region. Okay, that's the idea behind ANOVA. We want it to be the same or equal for each region. And again, for ANOVA, the null will always imply equal. The alternative then, and there's different ways for writing this, and I believe just from where I worked it earlier today in another class, it says at least one mean age is different. In fact, we can take a look at how it reads in D2L. Okay, so this is scenario 4. Whoops, went too far. It says the mean ages are approximately the same. Same implies equal, so that's the null. And then the alternative does say at least one is different. Now, again, there's other ways to say it, but again, trying to kind of help you with how the wording's going to be on the final. Okay. And I forgot to state the hypotheses, but you probably know the steps by now. All right, step 2, as we've been talking about, is to identify the players. Well, again, for ANOVA, that information is given to you in table form. Okay, so our players are this list or table of information. Of course, we also need our level of significance, which in this case is 0.10. And as a side note, remember that means my confidence level is 90%. Third step as always, is to calculate the test statistic, which in this case is F, and its p-value. So we have to go out to Minitab, and we're going to have to enter the data. Again, basically you have to enter this table. And again, you have a choice to make. You can continue to use the spreadsheet that you started with, but if you want to avoid making a mistake and have a clean sheet, just go up here and tell it you want a new project or a new worksheet, and it gives you a completely clean sheet. And we're going to enter the data. We have northeast, south, west, and east. And then we enter the corresponding numbers. Now, you want to be extra careful. Make sure that you type them correctly. Double check yourself, because if you mistype it, you're going to get the wrong answer. That's one of the things that I cannot really tell. If you have a wrong numeric value, I don't have the benefit of seeing your input into Minitab. So I don't know whether you just made an error or mistyped, or you actually did truly miscalculate. Okay, so I have all my data entered. Again, you might want to double check it. So we go Stat, Anova One Way. Stat, Anova One Way. My data are in separate columns, and I have to choose all of the columns where the data is located. Under options, we assume equal variances. My confidence level is 90, and it is two-sided. We click OK 2 times. And then we want to look for our analysis of variance table. And on that table, it gives us the F value and the P value, which we need to record. So my F test statistic is 2.40. The corresponding P value is 0.118. Step 4 is to make a decision. Again, we compare the p-value to alpha. Alpha was 0.10, and my p-value is 0.118. We're going to compare those digit for digit. 1 compared to 1, 1 compared to 0. 1 is greater than 0. The p-value is greater than alpha. If p is greater than alpha, we fail to reject the null. Okay, so again, thinking about what that means. If we fail to reject the null, that means the null is true and the alternative is false. So based on the evidence that we have, the mean age when the teenager obtained a license is the same for each region. And so we would say that when we write our conclusion. Well, at the 0.10 level of significance, the mean age at which a teenager obtains a driver's license is the same for each region. Questions? Okay, scenario 5 says, Miss Ralston is concerned that the 2 sections of her elementary statistics that she teaches are not performing at the same level. To test her claims, she looks at the second exam average from a random sample of each section of her classes. In class 1, the exam average of 26 students is 85.69 with a standard deviation of 10.78. In class 2, the exam average of 27 students is 87.59 with a standard deviation of 8.93. Test Miss Ralston's claim that class 1 and class 2 are not performing equally at the 0.05 level of significance. And it emphasizes here that class 1 is sample 1 and class 2 is sample 2. So one of the first things that I notice in this particular problem is that I have information about 2 different groups. Okay, so I have information about 2 different groups. It does use the word in the description. It talks about looking at the second exam average. So that word average, remember, is another word for mean. So I seem to recall that we had a 2 mean t-test. But if you look at our document, there were 2 different types of 2 mean tests. Of course, we use Z if the population standard deviation is known. And I don't recall anything about population standard deviation in this problem. So that's why I'm saying T. But we had independent groups, or we had dependent, matched, or paired groups. For independent, you have 2 different samples, and you're looking at basically 1 question. Okay. Matched, you have 1 sample and 2 different points of time. Well, this one I have 2 different groups. So to be specific, this is the 2 mean t-test, and we're looking at the idea that they're independent. But again, it gave me the word 2 and information about 2 groups, and it had the word average in it. So that's how I kind of got to 2 mean t-test. And I don't have anything that says population standard deviation. So step 1 is to state the hypotheses. And if you look kind of towards the end of the problem, it says, test Miss Ralston's claim that class 1 and class 2 are not performing equally. Okay, so it uses the phrase not equally. Well, not equally to me implies not equal. So that statement should be our alternative hypothesis. So the mean of class 1 is not the same as the mean of class 2. Not equally performing. If the alternative is not equal, then the exact opposite would be that they are equal. And we use the subscripts to indicate 1 and 2. Then step 2 is to identify the players. Now, everything you need is given in the problem. It's in sentence form. It starts with the phrase to test the claim, and it gives you information about class 1. It gives you information about class 2. And so the easiest thing to do is kind of to organize yourself in a table form with, we have class 1, which we're told is sample 1, and class 2, where we're told that is sample 2. And we need 3 things. We need the sample size, the sample mean, and the sample standard deviation. So if you go back up and read, it tells us that in a sample of 26 students, the exam average was 85.69 with a standard deviation of 10.78 for class 1. Continuing to read, it says for class 2, in a group of 27 students, the average was 87.59 and the standard deviation was 8.93. It also tells us to use a significance level of 0.05. Third step is to calculate the test statistic. Just going to be a t-test or a t-value and its p-value. And we're going to use Minitab to do that. So here we go. We go to Stat, Basic Statistics, a 2-sample T. We have summarized data. I was told that sample 1 had 26 students with a mean of 85.69 and a standard deviation of 10.78, excuse me. Sample 2 was 27 students with a mean of 87.59 with a mean of 8.93. Under options, it is a 95% confidence. My hypothesized difference is 0, and my difference is not equal, and we do assume equal variances. I click OK, OK, And again, my test results come up under test. Okay, so I have my t value and I have my p value from Minitab, which we have to record. So t is negative 0.70 and the p value is 0.487. Then step 4 is to make a decision. By comparing the p-value to alpha, we have 0.487 compared to 0.05. Comparing digit for digit, 4 compared to 0. 4 is greater than 0. P-value is greater than the level of significance, so we fail to reject the null. If I fail to reject the null, that means the null is true. The fact that it says equal, that means that the classes are equally performing. And the alternative is false. So I would say question 5, writing my conclusion. At the 0.05 level of significance, class 1 and class 2 are performing equally. Now, I believe on that question, let me double check and look because I think I remember this from earlier. Once you get to the end, it asks you to calculate Cohen's d. And if I remember right, that's a formula using information from Minitab. Okay. I believe it is the difference divided by the pooled standard deviation, if I remember correctly. Whoops, went to the wrong paper. Okay, so there's an extra step with this particular question because it wants you to calculate Cohen's d. And again, if I remember correctly, that is the difference divided by the pooled standard deviation. Okay, so that would be, and we get that information from Minitab, we have negative 1.90 divided by 9.88. And I'm going to get my calculator. Negative 1.90 divided by 9.88. And I get a value of, and let me get this out of the way. D is negative 0.19. Let's see how many places it said. Round to 2 decimal places. Okay, so here's another place where you might want to look at it, Jada, when you asked me earlier. 2, 3, 0, 7, Okay, so it wants 2 places. So if I need 2 places, 1, 2, again, I have a 2 next door, so it doesn't round up. So I'd have negative 0.19 is my Cohen's D. And then it wants you to determine, is that a small, medium, or large effect size? Well, remember, we have a PowerPoint that has that table on it, but I'm basing it off memory and just the fact that that number is so small, I would say small. But you need to try to locate that table. It would be on the PowerPoint, and I'll try to look that up for you and maybe make a note in the announcement about it. I don't want to take time to look it up now because we're going to run out of time if we're not careful. But I believe this would be a small effect. Right, scenario 6 says, for Americans using library services, the American Library Association claims that at most 67% of patrons borrow books. The library director in a town feels this is not true. So she asked a local college statistics class to conduct a survey. The class randomly selected 100 patrons and found that 83 borrowed books. Did the class demonstrate that the percentage was higher than 67%? Use alpha equals 0.01 level of significance. So again, thinking about which test you're doing here. One of the things that jumps out at me initially in this problem is that I have percentages. It says at most 67%. So that gets me to the idea of a proportion as opposed to a mean. I'm really only given one proportion in the problem, or it's only talking about one thing, the percentage of students or people that borrow books. So I have one proportion, and for proportion we use a z-test. So this is a 1 proportion z-test. Again, if you want to look at it on your document, 1 mean proportion, quantitative data, question about a percentage. I know the population proportion, and we compare the sample to the proportion. So that's where we are. Woo, same old, same old. First step, state the hypotheses. Guys, please be careful with this problem, okay? Because look at it. In the beginning, it says the American Library Association claims at most 67%. But then in this question, it said, did the class demonstrate that the percentage was higher than 67%? Because you need to be careful. It says it one way at the beginning, but the question is different. See, at most would imply less than or equal. But this librarian in this town believes it's higher. Okay, so be careful. You'll get tripped up. But the word higher in the question would imply greater than, which does not include equal, so that statement is your alternative. So I would say that my proportion, which is represented by P, is higher, is greater than the 67%. And remember, we convert that percent to a decimal. And this is the given in the question. The opposite of that would be that the proportion is less than or equal to the 67%. Step 2 is to identify the players. And again, you may not remember what you need to identify. Hopefully you have that written in your notes, but you need the population proportion, you need X, you need the sample size, and you need your level of significance. So my population proportion is 0.67. When the statistics class did its survey, it sampled 100 patrons and found that 83 of them borrowed books. That's the X. X was 83. The X is how many did what you wanted. I wanted them to borrow a book. And my level of significance is 0.01, which would mean my confidence level is 99%. Step 3 is to calculate the test statistic. And in this case, the test statistic is going to be a Z and its p-value. Mini-tab we go. Stat, basic statistics, 1 proportion. We have summarized data. The number of events is X, which was 83. We had 100 trials. We are performing a hypothesis test. We hypothesized that it was 67%. We are doing a 99% confidence level. My alternative hypothesis was that it was greater, and we do normal approximation. And I click OK. OK. We find our test. So we get from Minitab our Z value and our P value, which we record. Z is 3.40 and P value is 0.000. Step 4 is we make a decision. So we're going to compare the p-value to the level of significance. So I have 0.000 compared to the level of significance, which is 0.01. We compare digit to digit. 0 to 0, 0 to 1, 0 is less than 1, so P is less than or equal to the level of significance. When P is less than or equal to the level of significance, we reject the null. If we reject the null, That means the null is false and the alternative is true. So based on the evidence that the statistics class collected, it does appear the proportion is higher than 67%. So we would say in our conclusion, at the 0.01 level of significance, the percentage of library patrons who borrow books is higher than 67%. Questions? All right, scenario 7 says, the National Health and Nutrition Examination Survey is studying childhood obesity. The researchers weighed a sample of 546 boys aged 6 to 11 and found that 87 boys were overweight. The researchers weighed a sample of 508 girls aged 6 to 11 and found that 74 girls were overweight. Can we conclude that the proportion of boys who are overweight differs from the proportion of girls who are overweight? And it says boys is proportion 1, girls is proportion 2. Use a 0.05 level of significance. So 2 things in here jump out. One, it keeps using the word proportion. And since I have a proportion 1 and proportion 2, I'm kind of thinking this is a 2 proportion Z test. Kind of makes sense. So hopefully logically you can figure that out. So we begin, as we always do, stating our hypotheses. Okay, so we have the null hypothesis and we have the alternative hypothesis. And if we go back and read just a little bit, towards the end it says, can we conclude that the proportion of boys who are overweight differs from the portion of girls who are overweight? Okay, so in that sentence, I see this word differs. Differs would imply they're not the same. Mathematically, we represent that with a not equal, which means that statement is the alternative. So we're saying the proportion of boys does not equal the proportion of girls. You could use proportion 1 does not equal proportion 2. I like using the B and the G to indicate boys and girls. This is the given. The opposite would be the null. The opposite of not equal is equal. So the proportion of boys does equal the proportion of girls. Step 2 is to identify the players. Now again, for this problem, we got to keep the boys and the girls separate. So I've got to have information about the boys and I've got to have information about the girls. And you might want to indicate that boys are 1 and girls are 2. And we need the sample size and we need the X, how many were overweight. So if we go back and read our sentences, see if I can scroll this up just a little. It says that 546 boys were surveyed and found that 87 were overweight. 508 girls were surveyed and 74 were overweight. And we're doing alpha equals 0.05. So for the boys, there were 546 total and 87 were overweight. For girls, there were 508 and 74 were overweight, and we're doing alpha equals 0.05, which would mean your confidence level is 95%. All that information comes directly from the problem. Okay, question 3 is we calculate the test statistic, which again in this case for a proportion is a Z, and its p-value. All right, so I'm going out to Minitab. We go Stat, Basic Statistics, two proportions, I'm sorry. Stat, Basic Statistics, 2 proportions. We have our summarized data. For sample 1, which is the boys, there were 87 that were overweight out of the 546 surveyed. For sample 2, which was the girls, there were 74 overweight and out of the 508 that were surveyed. We go to options. It is 95%. The hypothesized difference is 0. My alternative was they were not the same. And we do, can't remember which one we used. Let me see if I can tell. One proportion to mean. Do I not have 2 proportion on there? Ooh, I don't have 2 proportion on your list. I'll have to go back and add it. I can't remember, guys. I think we did pooled. Okay, so we get our test. Okay, be careful because remember, we wanted to read the normal approximation. Okay, the normal approximation. So our p-value, or excuse me, our z is 0.62. The p-value is 0.538. We then go on to step 4, where we make a decision. By comparing the p-value to the level of significance. So I have 0.538 compared to 0.05. we compare digit for digit. So let's see, 5 compared to 0. 5 is greater than 0, so P is greater than alpha. If P is greater than alpha, we fail to reject the null. So thinking about what that means in this problem, if we fail to reject the null, that means the null is true and the alternative is false. So we've proven that the proportion of boys who are overweight does not differ from the proportion of girls. So I could take this statement that's highlighted in yellow and add a couple of words to get to my conclusion. At the 0.05 level of significance, the proportion of boys who are overweight does not differ from the proportion of girls who are overweight. All right, questions. All right, we got 3 questions left to go. I'm not going to make it by 8 o'clock, but let's see if I can get through scenario 8 at least. Scenario 8 says, in a recent poll, 668 American adults were asked their opinion on whether the government should prohibit smoking in public places. Additionally, each was asked how many people lived in their household. So if you'll notice, they're asking 2 questions of the same group. The responses, at least for prohibit smoking, were words: agree, no opinion, or disagree. The size of the household was a number. Okay, so if we think about this, we've got words in there. So again, that makes me think of chi-square because I've got words. And that's the only test that we looked at where we had qualitative data. I've got 2 questions. So let's see, that would be the test of independence, because I want to determine if the 2 factors are independent or dependent. So you have 2 qualitative survey questions. Okay, and it's presented in a contingency table format. So I believe that this test is going to be the chi-square test of independence. Again, the primary deal here is I have 2 survey questions, and one of them at least is qualitative data. So we begin by stating our hypotheses. For chi-square test of independence, again, the null has to imply equal, and the alternative will imply not equal. And the words we use for that are independent and dependent. So the null is going to be that the smoking opinion and household size are independent of each other, that one doesn't affect the other. The alternative would be that the smoking opinion and household size are dependent on each other. Okay, and it's always that way, guys, with the test of independence. The null will be independent, the alternative will be dependent. Step 2 is to identify the players. Well, the players here is this contingency table. Along with your level of significance, and it tells us to use 0.05, which means our confidence level is 95%. Third step, I know y'all are getting tired of hearing it because it's the same step we've been doing forever and ever, is to calculate the test statistics. So step 3 is to calculate the test statistic, which is chi-square, and its p-value. So I'm going out to Minitab, and again, I'm going to get a clean sheet so I don't get confused. And we're going to enter this table. In column 1, we're going to put the smoking opinion. Okay, and so that was agree, no opinion, and disagree. And then in the other columns, we're going to put how many household members. We had 1 household member, 2 household, 3 household, 4 household, 5 household. And then you got to fill in the boxes. Okay, so let me get this where I can see it. 73, 31, 42, 109, 52, 71, 48, 29, 38, 37, 20, 40, 37, 18, and 23. Okay, so I basically have recreated the table here in Minitab. We go Stat, Tables. It's called chi-square test for association. I've summarized data. my columns are 1 household, 2 household, 3 household, 4 household, 5 household. Okay, the rows are my smoking opinion, and the columns are my household size. And I don't think we need anything else. Nope. And we click OK. And it does a lot of work. And what we need are the results here for the chi-square test. Now, again, be careful because remember, we are reading the one for Pearson. Okay, we are reading the one for Pearson, and our chi-square is 6.377. The corresponding p-value is 0.605. Then we make a decision. By comparing the p-value to the alpha. 0.605 is the p-value. Alpha was 0.05. I compare them digit for digit. 6 compared to 0. 6 is greater than 0. P-value is greater than the level of significance. Therefore, we fail to reject the null. In this case, if I fail to reject the null, that means the null is true and the alternative is false. I have proven that the smoking opinion and household size are independent of each other. So I would say that in my conclusion, which is the last step. At the 0.05 level of significance, smoking opinion and household size are independent of each other. Okay, guys, I have 2 questions left. I have 6 minutes. I'm going to keep going and try to get through 9 so that you have the benefit of them all. Okay, I don't know if we'll get to the last one, but we'll see. So I'm reading this question. Do male college students and women college students eat 3 meals a day? The data below is collected from a random sample of college students at a historically black college and university. Use a 0.05 level of significance. So we have a question and we're comparing men to women. And so we have, again, qualitative data because you have male and female. Okay, so we're looking at gender, which are words, which is qualitative. So that immediately makes me think of chi-square. If I go back and look at my options for chi-square, when I have a single survey question and I have 2 different populations, that is test of homogeneity. So this is going to be a chi-square test of homogeneity. So first step, as always, is to state the hypotheses. The hypotheses for homogeneity are pretty much always stated the same way as well. Again, where the null implies equal and the alternative implies not equal. And so the question may give away what our hypothesis should be. Do they eat 3 meals a day? So we would say that college students, men and women, let's look at, so again, just so you'll have it as point of reference, I'm on scenario 9. They say the distributions are the same for male and female college students. Okay, so I was going to say male and female students eat 3 meals a day. Okay, so it says the distribution of 3 meals per day are the same for males and females. That gives you the wording that's in D2L. Okay, for the alternative, then we would simply say they're not the same. The distribution of 3 meals per day are not the same for males and females. Our information that we need for working the problem is this table. So step 2, when we identify the players, you're basically going to be using this table again, and you need your level of significance, which is 0.05. Confidence level, therefore, is 95%. Step 3, you're going to calculate your test statistic. Okay, I think you should know what that step is by now. The test statistic is chi-square. I'm trying to finish. And its p-value. So we have to go out to Minitab, and we're going to enter that table. And again, I like to use a clean sheet so I don't get mixed up. Okay. So we would have we're going to have gender on our horizontal, on the vertical in the first column. And then we're going to have usually eats 3 meals per day and rarely eats 3 meals per day. Okay, so we got usually and rarely. We've got male and female. We put in the numbers. Let's see, 26 and 37, 22 and 54. Okay, so then we go stat, tables, test for association. It's the same keystrokes that we had for test of independence. We just state it in a different way. We have summarized data. I have usually and rarely. My rows are gender. My columns are meals per day. I click OK. It does its thing. And I realize it's 8 o'clock. I'm trying to finish. You have chi-square, goodness of fit, or not goodness of fit, excuse me, test of homogeneity. And again, remember, we are reading Pearson. Okay, we are reading Pearson. We record it. My chi-square is 2.314, and the corresponding p-value is 0.128. When I compare the p-value to the level of significance in step 4 so that I can make a decision, I find that the p-value is greater than the level of significance. So again, we fail to reject the null. If we fail to reject the null, that means that the null is true and the alternative is false. So the distribution of 3 meals per day are the same for males and females. And you would state that in your conclusion. So we would say at the 0.05 level of significance, the distribution of 3 meals per day is the same for males and females. Okay, I realize it is 8:03. I do apologize for running over. There's one question that we did not get to that is related to correlation and regression. I will be going through this document with the Stat 2401 class on Thursday, and we'll hopefully get to that question, and I'll post that video so you'll have access to that solution. Are there any questions before we go? And I know we have run over slightly. Okay, 2 things to remember, guys. 1, mini project 7 is due Monday the 5th. Your final exam opens on Monday the 5th, and you have until Saturday the 10th at 11:30 p.m. to take the final exam. You do have to take it in one sitting, and you should allot at least 3 hours. I will be monitoring email, so if you have questions, you are more than welcome to email or pop in during office hours on Thursday or Sunday. If there are no further questions, I will see you guys. I don't know when I'll see you again because we don't have another class meeting. So I wish you the best on your final exam and hope your semester wraps up well and you have a Merry Christmas.
Thank you.
You're very welcome.